All right, welcome to The Explainer. Today we're diving into some really fascinating research that honestly, it challenges a core belief most of us have about math. What if the idea of math as this pure, perfect world of just numbers, what if that's actually holding us back from a much, much deeper understanding? Okay, so here's how we're going to break this down. First, we'll poke at that common assumption about math. Then, we'll uncover the invisible walls that have been built up inside our thinking. We'll look at a real-world problem to see the confusion this causes, and then we'll explore a new, unified way of thinking that brings it all back together. You know that old saying, mathematics is the universal language? It makes you think of these clean, perfect numbers that anyone on Earth could understand. But what if that's not the full picture? What if it's not even close? So this is the exact question that a researcher, Rogerio Santana Lorenzo, is digging into. His work makes a pretty bold claim that our view of math is often way too narrow, and it's time we really zoom out and see the bigger picture. And this gets us to the main argument here. The idea that math is just about calculation, totally separate from the words we use or the images we see, that's not some law of nature. It's a system that we built. And this research is all about figuring out how to put those pieces back where they belong. So how did we even get here? How did this separation happen in the first place? Well, by bringing together ideas from different fields like linguistics and anthropology, the research points to 5 major splits, or dichotomies, that have shaped how we see math, probably without us even noticing. Okay, think about it like this. On one side, we're taught about pure math, abstract, perfect, floating out there in the cosmos somewhere. But on the other side, there's the messy, real-world math we actually use every day, the kind that's shaped by our culture, our language, the problems we're actually trying to solve. The argument here is that these aren't two separate things. They're two sides of the very same coin. And these divides, they go deep. They create a wall between the official math you learn in a classroom and the common sense logic you use to, say, navigate a new city. They separate what we can say from what we can just see. Basically, they've put math in its own little box, isolated from all these other crucial ways we have of thinking and communicating. But here's the kicker, the crucial point. These walls, they didn't just appear out of nowhere. The research makes it clear that they are products of our history, of our beliefs about what counts as real knowledge. And knowing that, well, that's the first step toward being able to tear them down. Okay, let's make this real. Let's look at a concrete example from the research and see how this whole separation thing creates actual confusion for students. It's a geometry problem that seems simple on the surface, but man, it reveals a much, much deeper issue. So the setup was a question about building figures with squares and triangles, and it came with this picture of a dodecagon, a 12-sided shape. But here's the twist. The key piece of information you needed to actually solve it, it wasn't in the numbers. It wasn't in any formula. You had to figure it out from the context. Now, when you look at how a student answered, you see something really, really fascinating. They start writing in Portuguese with 2 triangles, and then nothing. It just trails off. The researcher points to this as an empty reference. You see, the student is trying to use a language to reason their way through, but the connection breaks. It's a linguistic failure, not just a math one. And get this, here's another one. A student writes about a square that's 16 square centimeters, and then in the very next breath says the square is 225 square centimeters. Wait, which one is it? Are there 2 squares? The language is so jumbled that it's impossible to even follow the math. The problem here isn't the calculation, it's the communication. And this right here, this is the core of the problem. The analysis found that students weren't just plugging in numbers. No, they were acting like detectives, trying to read between the lines and guess at the hidden rules the problem never actually stated. They had to figure out this whole logical rule about shapes that wasn't written down anywhere. They were trying to solve a language puzzle and a math problem at the exact same time. Okay, so if the old way is broken, what do we do about it? Where do we go from here? Well, the research doesn't just point out the problem. It actually offers a solution. A new way forward, built on 3 key convergences, which is just a fancy way of saying bringing language, number, and image back together. This new unified approach basically calls for 3 big shifts. First, we've got to treat reading a problem and counting within it as 2 parts of the same skill. Second, we need to actively teach language, numbers, and images as one single integrated system. And third, our big ideas about math have to be constantly connected to what's happening in the real world. In this slide, this just nails the difference perfectly. On the left, you've got the old way. Math, language, image, all in their own separate walled-off boxes. But on the right, you see the new vision. It's a connected, dynamic system where everything flows into everything else. Each part makes the others stronger. So this leads us to the big "so what" question, right? What does all of this mean for the classroom, for teachers, for students? Why does this new perspective really matter for all of us? So let's boil this all down. What are the big takeaways here? First, math is not some pure thing separate from the rest of life. It's tangled up in our language and our culture. Second, students are always using words and pictures to think, not just formulas. Third, those confusing answers we saw, they're huge clues, pointing to a breakdown between the words, the image, and the hidden rules of a problem. And that means for math education to really work, it has to teach language, number, and image as one integrated whole. And this research leaves us with one final, really powerful question to chew on. If we keep defining math so narrowly, if we only value the pure calculation part, whose genius are we missing out on? Whose brilliance are we failing to see? By opening up our definition of what it means to think mathematically, we might just discover a whole new universe of problem solvers we never even knew were there.